Hi, everyone. It's a pleasure to be here. My name is Sergio. I'm a customer engineer at SambaNova Systems. And I love my job because I help companies deploy the most sophisticated deep learning models in weeks rather than months or even years. And we'll talk about that. About my career. This is related to financial services. I grew up in financial services. The first decade of my life, of my professional life, was in financial services. I've done everything from quantitative behavioral economic research, product management, product design, even interned in wealth management. You name it, I've seen a large gamut of this industry. So I feel like I'm talking to my friends here. I decided to move to machine learning when I was working at a startup that sought to automate financial advice. And part of the reason for this is I was a product designer, and I thought that the work that the engineers were doing was really interesting, and I wanted to do it. So I went back to school, worked really hard, and I got a job as a data scientist at a federal government system integrator. That was great. I worked as a data scientist, then senior data scientist, then team manager. And what we did was we helped federal government clients deploy machine learning and artificial intelligence solutions. You know what I learned from that experience? AI is hard. It's really, really hard. And that's one of the reasons I went over to SambaNova, because we are simplifying a lot of the complexity that you see in AI. Let me see, press this button. Cool. So let me tell you a little bit about SambaNova. So we were founded by three really key people. So the gentleman on the right on that screen, you can thank him for a lot of the technology that's on your smartphone. Multi-processing, all these things. He's someone who's at the thought leader when it comes to chip design, professor over at Stanford, and is a thought leader nowadays, as you will see when we talk about our chip. The gentleman to the left is a thought leader for big data, machine learning, and artificial intelligence, and he's also a professor at Stanford. And the gentleman on the middle ran the chip business for Oracle for over a decade. They got together. There's a lot of confidence in this team. We've raised over $1 billion. We're the best funded AI startup. And this comes from a lot of leading investors. Intel, Google, SoftBank, and BlackRock. First time they invested in venture capital. Why? What do we do? Well, we're a full stack AI company. So we've come up with a chip. And what we do is we have a compiler that looks at this deep neural network architecture, and it lays it down on the chip. And what's ended up happening is the data flows, that's why we call it data flow architecture, through the chip. And as it's flowing, we're doing all the mathematical operations. Moreover, we're very good at memory. We have more memory on the chip, and we're much better at moving memory from the host system to the chip. And in the end of the day, why does this matter? Because it allows you to do these very large, complicated models in weeks, frankly, sometimes in days, rather than years. Let's talk about the market we're in. So according to McKinsey, it's a $360 billion market for deep learning and banking alone. And the industry recognizes this, so that 81% is respondents who say that they need to increase their investments in AI and ML. And that 75% is people who think that access to deep learning is key to innovation. That's good because AI is here. What does that mean? It means that there are firms making these investments today. And if you're not, you're being left behind. Deep learning is not the technology of tomorrow, it's the technology of today. So this is our slogan. I think it carries a lot of truth. Now, where do the industry leaders think that AI can make a difference for them? And a few things stand out to me here. Customer service, fraud, risk, and operations. And we're going to talk about these in three different buckets. These buckets include customer experience. They include operational efficiency. And so we'll talk about them. But first, why is AI hard? Now, the first thing here, the 71% talks about how difficult it is to hire talent. And I can talk to you about that from personal experience. When I was a hiring manager, how many resumes I had to go through? See, who seems to have the relevant skills? Who's done the correct model work. Let me go to their GitHub page. Let me look at their code. Does it look like they know what they're doing? Great. Bring these people in for an interview. Interview them. Unfortunately, 9 times out of 10, probably even higher, people fail the technical interview. Because this stuff is hard. There's a lot to it. You have to know how to write code. You have to know about systems. You have to know about architecture. You have to know about chips. You have to know the math. It's really, really not easy. And the people who are good, and you can usually tell who's good within the first 5 minutes of an interview, they're in high demand. So if they want to come work for you, great. But they have offers from like 5 or 6 different people. And are you going to be the ones going to be able to get them? I hope so. But it's really hard. The next thing here is the 67% is talking about keeping up with the technology. I had someone in my team, when I was a team manager, who almost their full-time job was to stay on top of the industry. What are the algorithms? Read the papers. Educate the rest of the team. Who are the vendors? Because this is an ecosystem. You need things to work together. And that almost became a full-time job for 2 years for this person. And that was important because that brought a lot of value to our clients. So, and that's from someone who's a subject matter expert, already devoting, worked really hard, this guy, full-time, just to keep up with the industry. And the last thing here is about the time horizon to return on investment. Years, months, I mean, you want to shrink that as much as possible so you can start seeing a positive ROI. So we said we'd put these things into buckets, so let's talk about the first one. You have a problem. You go to the company website, a little chatbot comes up. It's useless. Doesn't help at all. So you look for the company phone number. Can't find it. So now you have to Google it. You find it. You call them. Someone picks up. You give them your information. They can't help you. They transfer you to someone. You have to give them your information again. They look it up. Maybe they help you. And then, oh, here's will you take 5 minutes at the end of this call to do a brief survey? You probably won't. Or maybe you're one in 20 people who do, but you're only doing it because you're really annoyed, and you want to let them know you're annoyed. Raise of hands, who's had this experience? All right, if you're not raising your hand, I think it's because you don't want to participate, which is OK. Let me tell you about something that happened to me this week, and I'm not making this up. This literally happened to me. I couldn't find my glasses. Look for them everywhere. Can't find them. So I go to the website where I ordered them. I go to my orders, and I reorder them. Of course, 5 minutes later, I found my glasses, right? So I got to cancel my order. I don't want to spend money for something I don't need. How do I do that? I go to the company website. I go to my orders. I don't see a button, but a little chatbot comes up. OK. How can I help you? Chatbots are useless. Well, let me at least try. I need to cancel my order. Your order's been canceled. Seriously, that easy. That's the difference between a good chatbot and a bad chatbot. And what goes behind the scenes to make that happen, that's what we're going to talk about. The promise for good customer service that's AI-enabled is huge. Do you guys think I want to order from somewhere else? No, I'm going to keep buying glasses from the same place. Improved revenue. This company, overall, because they're using a chatbot to handle low-level requests like this, they don't have to have a human do it. Humans are more expensive. And so what that means is that when a problem goes to a human, they're dealing with higher-level things, which, if you think about it, if you're the customer service representative, that's more enjoyable work for you. It's a win-win. There's also innovation. Because the same algorithms who can help you do this kind of work are the same algorithms who can suggest, hey, Sergio, maybe you want to look at these frames instead. Yeah, maybe I do. So there's a lot that goes to these algorithms. So let's talk about a little bit about the technology behind this and how can it be applied to banking. So NLP, natural language processing, you probably all heard the term. It's the math behind how do we take natural language, so how humans speak to each other, and do something with it. The cutting-edge models nowadays are GPT, generative pre-trained networks, and they have state-of-the-art performance for a variety of tasks. The problem is if you get an off-the-shelf model, GPT, even if it's the cutting-edge model, it's not going to be all that great until you train it more for your specific use case. And that's not easy. We'll come back to this at the end. What we've done is we've come up with a GPT model for banking specifically. So we trained it on an enormous corpus of banking-related data, so that way you can have value faster and shrink the time to return on investment. So let's talk about this call center journey again and how it works. So I call someone, right? I ask them the question. They look it up. They pass me over to someone else. Then hopefully they give me an answer, call-ins. Maybe I do the survey, probably don't. There you go. What you can see here, it's not really self-reinforcing. How is this going to get better by working like this? Well, let's say we put in GPT banking in here instead. So I call. I explain what my issue is. The thing automatically routes me to the best person to help me with my issue. Great. Then the system also provides what the best possible solution is to the client server's representative on the line. So they probably don't have to pass me over to somebody else, and they get me the answer quicker. Moreover, at the end, instead of the call center representative having to write everything down and put it in the CRM, Customer Relationship Management System, it does that automatically. Moreover, it can use sentiment analysis from the algorithm itself to figure out how did the call go. So 100% capturing that information. Now this is something that you can use to be self-reinforcing and to make improvements upon itself. Operational efficiencies. We talked about 3 buckets. Let's move on to bucket number 2. So according to Accenture, 85% of the leading AI companies want to use AI to reduce costs. We saw in the call center example of how that could work, but I really like the second box here with the 70% drop in false positives. Have you ever, say you're traveling, road trip, you're in a different state, you stop at a gas station, you need to buy something, use your credit card and you get a text. Was this really you? In some ways that's great, because it shows that the bank is trying to prevent fraud, so I appreciate that. But sometimes you're in the middle of nowhere. It's a big country, right? And sometimes you don't have service there. So you're really going to get the text. I've lived through this, and it's pretty annoying. So using these models can lead to a 70% drop in false positives, meaning I'm much less likely to get that text, and my transaction is much more likely to go through. As a consumer, that means a lot to me. I'm more likely to bank with the institution that offers that. Now, there are many areas in this industry where you can apply these algorithms. In fact, this is probably the most data-heavy industry in the market, or of all industries. And we talked about customer experience, how you can do that. Credit, so should I give credit to someone or not, and so forth. But I really want to focus on compliance. Compliance is really hard. According to Accenture, compliance accounts for 8 to 10% of the revenues for large financial institutions. That's a really big cost center. Compliance is really hard because there's a lot of rules from a lot of different places, from the state, from the federal government. If you do work overseas, from those governments, it's hard. It's very document-driven. So in a way, it actually is one of the perfect places for you to apply these models. According to Accenture, you can have 200 to 300% productivity gains when you're using good deep learning models in the compliance framework. So think about it. You need to find out about an issue, and there's thousands of pages worth of documents. Well, what if you had a search engine-like capability that's very smart and can show you, oh, here are the paragraphs from the different documents I think you should be looking at. Makes your job way easier. I remember one of the reasons I wanted to get into AI is because I read a book, and the book talked about how that these algorithms were better able to detect disease in X-ray images than some doctors are. And then I literally talked to some doctors who were afraid that these algorithms were going to take their job. But it's actually quite the opposite. There are not enough professionals who can read these scans to service the population. These algorithms are great in helping these professionals see more people and be more efficient and effective. And the same thing happens here with compliance professionals. And I think that if your job isn't to read through a bunch of documents where most of it is not relevant, that makes your job easier. It makes your job more fun. It makes you more engaged. It makes you more productive. Again, I think I see a win-win-win here. So our vision is you can apply these models. You can do everything from content summarization, that's a big one. Say you need to figure out an issue about a specific individual, named entity recognition. There are many different facets for what these algorithms can accomplish that can help you do your job. Let's talk about innovation. And this is probably not going to start how you expect. So according to the Financial Times, fines for anti-money laundering lapses were 5 times bigger in 2020 than 2019. No COVID slowdown. Why? Well, it's because in this cat and mouse game, the criminals are getting smarter faster. And frankly, it's because a lot of the tools that are being used to combat this are not keeping up. Why is that? Well, I love this chart. Basically, what it's saying, if you looked at the blue line, is that machine learning algorithms, which is what a lot of the compliance tools are based off of, they have diminishing marginal returns. And the problem is that we have to analyze data from a greater variety of resources, data that's not just structured, columns, rows, labels, data that's coming from a variety of places. When I was working with defense, one of the things we talked about was OSINT, or OSINT, which is open source intelligence. Can you look at social media? Can you look at news articles? Can you bring all this information together, greater amounts of information? Machine learning models are great for a variety of tasks. For this type of task, they're not up to the challenge. Deep learning models, on the other hand, can handle the greater variety of data, and they can handle larger amounts of data overall and not start losing their accuracy. They're not suffering, at least not yet, from this diminishing marginal return. But it doesn't just have to be in compliance. If anybody here is in asset management, have you had to ask yourself the question over the last 12 months, which firms are going to be most impacted by the chip shortage? How do you do that? You go through 10Ks, 10Qs, news articles. You have to go through a whole variety of sources. And if you've ever read a 10K or 10Q, you know that the majority of the data there is in the footnotes, and those are very boring, no matter how enthusiastic you are about this industry. But that's where the gold is. You have to mine for gold. The beauty about using these algorithms is that they can help you summarize that information and figure out where you need to look. They're not here to displace, they're here to empower. And it doesn't just have to deal with trade signals being backwards looking, but do you want to ask yourself questions about, well, what industries may be impacted by name the scenario? That can help you think of trade ideas. That can help you be prepared for the future. Let's look at a case study. Now, SambaNova Systems was founded in 2017. 5-year startup at this point. How cool is this? We're building the fastest AI supercomputer in Europe by working with OTP Bank. Let me tell you who OTP Bank is. It is the largest commercial bank in Hungary and one of the largest financial institutions for Central and Eastern Europe. A problem that they came to is that artificial intelligence underserves these markets. Do you want to find a cutting-edge model in English? Go. Get your PyTorch. Literally, in one line of command, you can download a model. You still have to train and do a lot of other stuff, which is really complex, but you can get the model. Want to do it in Spanish? Todo bien. Portuguese? Vai funcionar. But you want to do it for Hungarian? It's not there. Hungarian is a very complicated language. And all these other languages for these Eastern European countries are also underserved. So we were able to come in and partner with them to train models that look at these different languages, so that way they can do a lot of the things we're talking about. That way they can be more innovative. Maybe a customer doesn't want to invest in companies that sell cigarettes, tobacco, or oil and gas or something. Well, when people have such strong feelings, they're going to go to the provider who caters to those feelings. Maybe they want to apply it to their operations and gain some efficiencies there. Maybe they want to have really good chatbots. Well, all these things are true, and we're working with them today to make it happen. It's very exciting. We're starting with Hungarian, then we're moving on to other complex languages after that. What's the difference that we make? Why look at us? It's a fair question. So over here talks about the process to getting these really large, complicated, sophisticated deep learning models to work. So let's say you go through some of the difficulties we talked about before. You manage to find talent, you manage to give them competitive offers, and you manage to hire them. Then you have to figure out in the ecosystem, who do you want to work with? How do you tie it to your ecosystem? Then you have to get the model. You have to train it to your specific use case. We're talking about 8 months at least have gone by, if not a year. Well, we can shrink that time period because we can offer you a solution that is already pre-trained to your specific use case. And if you look here at these bars, so if you look at BERT, for example, which is one of these leading edge models, so 76% accuracy on financial-related data. Our GPT model is 83%. That's where you start getting that difference between that chatbot that's less than useless and is an irritant versus something that actually helps you. Want to learn more about us? We're at SambaNova.ai. My colleagues and I will be at our booth for the rest of the conference. It'll be a pleasure to talk to you guys. And I think it's time for questions, right?
Yes, sir.
Awesome, thank you. If anybody has any.